Or the kinetic energy of an object traveling with the speed and state. What any other terms in the equation represent?
So this one is related to kinetic energy, right?
Yes, sir.
Kinetic energy formula, you know, half mv square, right?
Half mv squared.
Then continue.
The mass of the rock is 0.6 kg. When it hits the earth, its average temperature increases by 25 degrees Celsius. The specific heat capacity of the rock is 560 gram kg per kg degree Celsius. Calculate the increase in the internal energy of the rock.
Yeah, joule per kg degree Celsius, not gram. Okay. So this one is related to specific heat capacity formula, right?
Heat capacity. Yes, sir.
So specific heat capacity formula, you know, that is C equals Q by M del theta,
Q
right?
by m del theta.
And you are going to find energy. So it will be Q equals MC del theta, right?
Yes, sir.
So write this formula. Now, beside here we have blank space, right? Uh, so left side you write the formula for energy, internal energy. You have here basic formula C equals Q by M del theta, right? So
Yes,
Q
sir.
will be MC del theta. You memorize it, memorize it, memorize it, because this formula will come in your test. You have to memorize this formula. Q equals MC del theta, and you have to put the values correctly over there, right?
Yes, sir.
Okay, then
Use the answer from B1 to determine the minimum possible speed of the car.
of the rock,
Sir, 1 minute.
of the
Of
rock,
the rock, okay, of the rock when it
it's the
hits the
earth.
earth.
So you are going to find the speed
Yes, sir.
from kinetic energy formula.
Kinetic energy formula.
Yeah. So kinetic energy formula you got K equals half mv square. If you rearrange, it comes V equals square root of 2 K by M. So this one you have to
Then
memorize. If you convert kinetic energy formula, it's coming V equals square root of 2 K
sir,
by
you will
M.
give the
Okay.
question paper in the whole classroom.
Sorry.
Sir, in the test you will give the question paper in the whole classroom.
Yes, Google Classroom, and it will be in Google Form. Okay, you have to answer it, write it in Google Form. Okay, you will do the working on your copy and you will write the answer in the Google Form. Okay,
Okay, sir.
is it clear? Like
Yes, sir.
if they are asking you the speed in Google Form, you do not need to write or calculate everything. You will calculate all these things in your copy. Okay,
Okay, sir.
at your home in your copy you will calculate
Just will
everything.
write the answer.
Yeah, and you will use the calculator and write the answer over there correctly. That's your task. Okay,
Okay, sir.
now next part.
Sergeant, one reason why the speed determined in B2 is less than the actual speed of the rock when it hits the earth.
So in this type of questions sometimes you will get that why the energy is less, why the speed is less. This type of question there is a common answer,
Heat
because
loss,
there is heat loss in the surrounding. Okay,
energy, surrounding.
because the heat is lost in the surrounding. So Here you write is loss in surrounding, huh?
Surrounding.
And in surrounding as what you wrote here, because there is heat loss in the surrounding. That's it. Don't write this energy.
Okay, sir.
Just here write cut energy, then you write surrounding. Okay.
Okay, sir.
Now continue.
A house has several solar panels on the roof. These panels use energy from sun both to generate electricity and to raise the temperature of water that passes through the tubes inside the panel.
Yes. Then
At the same time,
check your
51
check your worksheet, huh?
I'm checking my one.
Because it's not clear. Yes, Farabi. Farabi.
Yes, sir. Hello.
Yes, you brought your worksheet.
Yes, sir.
Look, we have the same formula here. This formula is coming again and again. So be careful. The same thing is
Yes,
coming
sir.
again and again. We did in MCQ part. Also, we are doing in structured part. If you are doing wrong with this formula, then it will be really very shocking for me. Okay,
Okay, sir.
you shouldn't do any mistake here. Be serious and memorize this formula. Q equals mc del theta. Okay,
Etc.
C equals Q by m del theta. So how this del theta is coming? Increase in temperature, right? 40. The temperature raised from uh, how what degree? 16 degree to 45 degree,
16
right?
degree to 45 degree.
And specific heat capacity is given C, and the mass is given 5.1 kg, right?
Yes, sir.
So these things you have to find from your given information in the CT paper. You should check it out and find them. Then you put in the formula. Don't go for shortcut. Don't do only on the calculator. You write it on your paper, do it, then you calculate your calculator. Okay, otherwise there will be mistake. Now we have here mm, the state ways which the molecular structure of gold is 1200 degrees Celsius differs from the structure of 100 degrees, 1000 degrees Celsius. So they are actually
Yes, yes,
asking you about the difference of solid and liquid, right?
yes, sir.
Because melting point gold is 11 degrees Celsius, 1100 degrees Celsius. So at 1200 degrees Celsius, it will become liquid,
Yes,
and
sir.
at 1000 degrees Celsius, it is solid, right?
Solid,
That's why they are indirectly asking you the structure of solid and liquid.
liquid.
This way you have to analyze the questions, huh? Uh, that how the question is asking you, what they are asking you. You should analyze, then you have to answer. Okay. Then you have this one very important. Look, explain in terms of why thermal energy is needed to melt the gold. So melt the gold means you are going from solid to liquid.
Liquid.
In liquid molecules, they they have particles are going far away, right?
Yes,
In
sir.
solid, they are tightly packed. So to break the bonding and to overcome the intermolecular force, we need some energy, right?
Yes,
And
sir.
that energy is coming from the thermal energy. This way, wonderfully, you have to write if you are getting this type of questions. Then you have to memorize this formula. Look, specific latitude. This formula also will come. This type of questions will come. Okay, so you have to analyze these questions again and again. You revise your worksheet and check out you can solve them or not. Look here, you did not write the unit. You should write the unit. Your uh, your answer you got 53.76.
70.
53.76. How you got? You multiplied with
64
64 and
into 0.8
multiplied 0.84 kg. So your answer is coming in kilojoule, right?
kilojoule.
Because the specific latitude is given in kilojoule. So write the unit correctly. Huh? If it is given in joule, then your answer will be joule. Huh? If your answer is in kilojoule, then your answer will be in kilojoule. Is it
Kilojoule.
clear,
Yes, sir.
Paravi? And some of the questions they are asking you to find the mass. Remember, if they are giving here kilojoule per gram, uh, if they are giving the answer in kilojoule per gram, then your answer of mass will come in gram. Is it clear, Ravi?
Yes, sir.
So you should be careful in taking the units. The unit of specific latent heat is given in kilojoule or joule per gram, or it is given in kilojoule per kg. So accordingly, your answer should be written here for measuring the mass. Okay? If they ask you to
Yes, sir.
find the mass, then what will be the formula? Huh?
Kilojoule.
Formula. I'm asking you here. They gave you L equals Q by M. That
U
means
by
you are
M.
going to you are going to find Q, then you are converting to Q equals ML, right? But if they are
Yes, sir.
asking you to find the mass, then what will be the formula?
Yes, sir.
M equals what?
So, uh, Q by Q by L.
Very good, very good. This way, so you write here formula for measuring mass. You might get a similar question that one will ask you to get the mass. Okay, and you careful there. There is given kg or gram. Okay, this way right here. This place you write formula to get mass. Formula to get mass what?
Yeah, M equals to Q by L.
Write this way Q by L. Okay,
Okay, sir.
then we are going to next question 3. There will be one question on specific heat capacity formula and one on specific latent heat. That's why you you practice again and again this formula. Okay,
Okay,
then
sir.
continue 3.
A particular type of cooking oil in a liquid at room temperature. Some of the oil is poured into a metal pan. The oil in the pan has a mass of 680 gram. The pan is placed on an electric hot plate as shown in figure 3.1.
Yes, yes. Then yeah, then continue.
Yes, sir. 1 minute.
You can't see the screen.
Yes, sir.
Hmm. Because this part is clear. You can see from the screen. You can read from the
The
screen.
specific heat capacity of the oil is 2.0 joule per kg gram degree Celsius. The oil is heated from 20 degrees Celsius to its boiling point of 260 degrees Celsius. State what is meant by boiling point.
Okay, so boiling point definition you should learn, right?
Sir.
What is
The
boiling point?
temperature of liquid turns to vapor is called boiling point.
Yeah, you should write here the temperature at which uh, the temperature at which liquid turns to vapor on heating. After writing vapor you give you write also on heating. The temperature at which liquid turns to vapor on heating, because for boiling we have to give heat from the outside. Okay, external heat should be given from outside.
Hello?
Yes,
Calculate the thermal energy needed to heat the 680 gram of oil to its boiling point.
look here, it's very important that 680 gram is given in gram, but we did not change the unit. Why? Our specific heat capacity is given in gram, right? Joule per gram degree
Gram.
Celsius. So you be careful. If this unit is given in kg degree Celsius, then you have to convert 680 gram to kg. Is it clear?
Yes, sir.
So you note it and you be very much cautious during test that your units, how they are given and how they want you to write, how they want you to get. Is it clear? So they are asking you to find the thermal energy, calculate the thermal energy needed to heat the 680 gram of oil to its boiling point. So your thermal energy, you wrote this formula. Is it correct formula? I don't think so that it is correct formula. You write it correctly because the main formula is C equals Q by M del theta.
M del theta.
You wrote it wrongly. It should be C equals Q by M del theta.
Q by M del theta.
Yeah. Then Q will be MC del theta. You cut it, then do it again. But you wrote the answer correctly. If you calculate this way, the way you gave here, it will not come like this. Do you understand?
Yes, sir.
So you cut everything here and write here clearly. Your formula should be C equals Q by M del theta. Then next step it will be Q equals MC del theta. You put the values correctly, then you'll get this value. Check it. Look here, you did mistake. Now I'm writing again. C equals Q by Q, right? Q by M del theta. I have no option here to write del theta. So what can I do? I can do here annotation del theta M del theta. Okay. C equals
Okay.
Q by M del theta. Then Q will be MC del theta. You write Q equals MC del theta. Write it correctly. Q will be MC. Again, I have to annotate. Are you writing, Farabi?
Okay.
Please write it. Del theta, I'm writing. Okay, MC del theta. Then you put the values. All the values you put here, then you will get the answer. MC del theta then equals your M is 680, right? 680. Then C is how much? 2. Then del theta how much? 260 to 20 to 260. So you are getting here 240. Look, you did also here mistake. You wrote only 60 to 20. So it should be 260 minus 20, 240 del theta. Then check the answer. Is it coming like this? With calculator you check.
Yes, sir.
Arabi.
I'm checking.
That's why I told you to send me the worksheet so that I can check. Otherwise, I
Sir, the
couldn't
answer
check.
is same.
So, do you understand what I'm saying? Why I said you to send me it? Huh?
Yes, sir.
Arabi? Do you
Yes, sir.
understand now why I told you? So, is it helpful for you? If you send me,
Yes, sir.
so your answer came correctly. That is 326400. Then you wrote 3.26 into 10 to the power 5, but you did not write the what? Unit. What should be the unit here? Can you tell me what should be the unit? Thermal energy?
The joule per gram.
No, energy. Energy is always
Joule.
joule. You see,
Joule.
also here is given joule. If they are giving here kilojoule, you give here kilojoule. Okay.
Okay,
Now
sir.
they gave you joule, so you write here only joule. Energy is always in joules. Okay. But it will never be joule per gram. Joule per gram means you are dividing energy by mass. That is coming in specific latent heat. Is it clear?
Yes, sir.
Don't make a mess. You be very much clear about your ideas. So you cut this part. This part you cut. Hello, Farabi.
Yes, sir.
Left side you cut and right side whatever I wrote, you do this part. Huh? Correctly. Correct your paper. Now, now we are going to next. Huh? Suggest one reason why the energy output from the hot plate when heating the oil is larger than the value calculated in C2. So same way you got like before, right?
Yes, sir.
Actual energy we are giving uh, actual energy we are giving actual energy actual energy we are giving is larger. You write here, huh? Is larger. You are losing some words. Actual energy we are giving is larger because some of the energy lost in surroundings. Okay, you are getting the same thing again and again, so you remember this point. Some energy is lost in surroundings. Did you write that one? Hello, Ravi, did you write this one? Actual energy we are giving is larger, huh?
Yes, sir.
Okay, now question 4. Please
Yes,
go
sir.
through question 4.
Suggest one reason why the figure 4.1 shows a kettle containing a water placed on the burner of a gas cooker. The gas burner is lit at a time t is equals to 0 at 250 seconds. The temperature of the water is 100 degrees Celsius, the boiling point of water. State what is meant by boiling point.
State what is meant by boiling point. The same definition came. The temperature at which uh, liquid turns to vapor on heating. Correct it, huh? There will be no off here. The temperature at which liquid turns to vapor on heating. Never forget this, huh? This definition. So if I ask you what is called melting point, can you make it? Paravi? Hello, Farabi.
Yes, sir.
What is called melting point? Can you write it here? Here you write, then tell me what you wrote. Melting point. The way you are getting boiling point, same way we will make
Melting point.
melting point, but there you'll write only solid turns to liquid, right?
Liquid.
Other things are same. Melting point.
So the temperature of solid turns to liquid is called melting point.
Again?
The temperature of solid turns to liquid is
No,
called
no,
melting
no,
point.
no. The temperature at which I told you to correct it, right?
So at which
The temperature at which solid turns to
solid turns to
liquid
liquid.
on heating. On heating. On your worksheet you write it, huh? Armin, are you writing? On your worksheet you write. Then you just read from there. I can hear correctly.
So the temperature at which solid turns to liquid
On heating.
on heating
On
is
heating.
called
Also
melting
write
point.
on heating. Did you write on heating?
Yes, sir.
Okay. Also correct it here, huh? Here for boiling point also write here on heating. So this one is showing you the graph. Which one is a curved line? Ah, and again we are getting the kettle contains 1.5 kg of water, which has a specific heat capacity, right? I can't see the value here. It's not clear. Or using figure 4.2 determine the increase in internal energy of the water between T equals 0 to T equals 250 at 0 degrees Celsius. So here you got C equals Q by M del theta, right? Farabi? Hello, Farabi.
Hello, sir.
Yes, you make the formula correct here. The left side one, you wrote Q equals C by M del. So you correct it. C equals Q by M del theta, okay? The right side is okay. Q equals mc del theta, but the left side you did mistake. You cut it and write here C equals Q by m del theta. Did you correct it?
Yes, sir.
Then you have mass, you have a specific heat capacity value 4200. Then del theta means at 0 time 0 the temperature was 24, and at time 250 seconds the temperature was 100 degrees Celsius, right? Hello, Arabi,
Hello, sir.
is it clear whatever I said?
Yes, sir.
Okay, so we have here 4.8 into 10 to the power 5 joules. Look, the unit is given in joules. The answer is given. Answer is also coming in joules. Okay, and here the mass is given in kg. Specific heat capacity also given in kg. Are you seeing your copy, your worksheet?
Yes, sir.
So why the you see temperature increase rate is not constant. If the graph is a straight line, then we understand the rate of the temperature increase with time. It is constant, but it's not giving you a straight line. It's a curved line. So with time, the temperature increase is not constant. So what is the reason? Reason is there is possibility to heat loss in the surroundings, and the room temperature is not constant. At higher temperature, heat loss is greater. Heat loss is greater, is
Great,
not
sir.
it. Okay, state what happens to the temperature of the water. Temperature remains same. At boiling point, we know there is fixed temperature. The water boils. That time, what will be the temperature of water? It will be same. Now, the last part, explain in terms of molecules why it is necessary to supply thermal energy in order to keep the water boiling. So we got this idea before. They have fixed volume but does not have a fixed, and also their density is high and they are not compressible. Look, for this one, we we said you one idea before. You should write that idea. Uh, can you remember what we said? Why we need thermal energy to keep the water boiling, to break the bonding, right?
Yes, sir.
So you write here to overcome intermolecular force. To overcome the intermolecular force, we need to do some work to cut this. To overcome the intermolecular force, we need to do some work the way you wrote it before. The same thing you have to write. That's why thermal energy is needed. Are you writing?
Yes, sir.
It's like before, you wrote before that one. To overcome intermolecular force, we need to do some work and that's why we need thermal energy, right? Are you writing, Farabi? Farabi? Hello? Hello, Farabi? Farabi? Farabi disconnected.